So good morning. I think it is the morning. It's probably the first time I have questions before I even start the talk, but that's a good thing. It shows there is interest, I guess. So yeah, I'm the co-maintainer of Geeks together with Ricardo, which you've probably seen this morning, or you should have seen maybe. I'm going to talk about GuixSD, which is a free GNU Linux distribution, and about how we manage system services in GuixSD. So I'm pretty sure the Intertubes has already started making fun of me because I'm, supposed to be the maintainer of a distribution, and I'm just, claiming that I recently discovered what a system service is. I'm pretty sure people are making fun of me. But anyway, so yeah. First of all, let me maybe do a recap of what GuixSD is. How many of you have a feeling, like how many of you have used it or read about it? Okay, 100%. That's that's pretty good stats. Okay, so, well, as you know, GuixSD is that free distribution where you can basically declare what your operating system is going to look like. So that's different from most distributions we're used to, like Debian and all the traditional distributions, because instead of logging in as root, installing packages, and fiddling with files in etc, you go right from the start and you write this configuration file, and that's it, right? That's how your operating system is going to be. So previously, John Darrington talked about the graphical installer for Geeks, which is just brand new. And until now, you had to, when you were installing GuixSD, you had to actually write this kind of configuration file or start from a template and actually instantiate it live from the USB installation image. So what is it telling us? Well, here we see a number of useful pieces of information, like we have the local time zone, user accounts, file systems, and so on and so forth. And we have this last bit here, which is what I'm going to talk about, which is system services, right? So that's usually the most important part, I would say, maybe of the system configuration. And it's also the most difficult part, the thing that is pretty hard to get right? So we have sort of conflicting requirements here, because for GuixSD, we want to make it as simple as possible for users to, choose what system services are available, what options they use. But at the same time, we want to be able to handle pretty much any kind of system service. So the thing is, we want to be able to have essentially just one line per system service in the configuration that people actually write. But it should be able to handle complex, service compositions. So I'm just showing briefly what users sees and what users actually type in their configs. So here we have two additional system services. So we're saying I want to use the basic system services like a login, console, and so on. And I want to add a couple of services to them. So the first one is a DHCP client, so I can get networking, and the second one is the SSHD service, the SSH daemon. And I'm just using default configuration values here. But of course, we want to be able to, to specify options to that. So let's say, for example, for OpenSSH, I can just write this thing here. And, if you're not familiar with Scheme, that's okay. You can guess what it's going to do, right? We have an OpenSSH configuration object here that's being instantiated. And we're saying, I want to set this particular field x11 forwarding to false, and this other field to that thing, and that's how you customize services. Okay. But sometimes also you want to be able to say, okay, I want to use the desktop services, which is to say that all the services that you expect from a desktop style installation, which is a graphical server, maybe GNOME, maybe that kind of thing, networking and all that. Except that there's one thing I don't like, so I want to remove it. How many people are familiar with Scheme in this room? Oh, yeah, that's 90%. Okay. Well, the thing is, this is scheme, right? And you have to know that remove is a procedure that, you know, you give it a predicate here and it removes item from the list, which is the second argument. That's essentially the story. And so lambda just means this is a function, right? It takes one argument, which is a service. And if that service is a service of type NTP, well, that's the one I want to filter out, okay? So here I'm just saying, okay, I'm removing the NTP service from my machine because it's in this list of default desktop services, but I don't want to have it. Okay, so this is just standard scheme. We're just manipulating values which happen to be services. Okay. Sometimes you want to be able to do more complex modifications, like again, you want to be able to use those desktop services because it's pretty complete and so on. But you want to change a few details. So let's say you want to change the way, you know, the min get TTY login thing welcomes you, like you want to change the message of the day. That's something you can do this way using the modify services thing. And here we're changing the way you power, so the power management service, you know, handles various events, and that's something we are doing here, right? And again, this is still a simple scheme list of objects, service objects, and so we can have variable holding that thing, and so on. So, if you're used to Puppet or Ansible, I know the person sitting next to me right before is presumably using Puppet or maybe hacking on it. Well, you know, this kind of declaration is not very different after all, right? It's just you specify all the details of your operating system and then you run Puppet or Ansible something and you get your system which is going to instantiate roughly what you asked for. But there's a pretty big difference, I would say, between GuixSD and Puppet, which is that in GuixSD, this is functional in the sense that you give it a configuration and you get an operating system instance, right? And you can do that, you know, anytime on any machine. You'll always get the exact same result, even bitwise, modulo maybe a couple of packages that are not bit reproducible, right? So that's a very strong kind of guarantee. Whereas if you're using Puppet, well, Puppet is essentially trying to modify the state of existing machines by running new commands and so on. And so if everything goes well, you'll end up with pretty much the state that you asked for. But in some cases, you know, you might have problems. I don't know, maybe we can discuss it afterwards. But yeah, it doesn't always work from what I heard. So that's the story. So what do we do with this configuration? Well, we have a bunch of commands. So we have the Geek system command, which is a central dispatch kind of command for GuixSD. And essentially, we always provide one of those configuration files, and then we can do a bunch of things with them. So first thing is we can build the system. So let me just show an example. Where is my shell? Oh, okay. Yeah, it's gonna get better afterwards. Yeah, so here I'm just running Geek system build some file. And what I'm getting here, I'm just getting as a result one of those big directory names that you should be used to by now with a hash, which is actually hidden in this case. I can show it just for the sake of it. So this is the big hash, right? And you know, it doesn't seem very useful as such, right? It's just a directory, but what's in there is that there's actually everything that defines the system instance. So if I jumped into that directory, I see a bunch of entries. So the first one is boot. It's actually a boot script. I probably don't need to go into the details here. There's etc, which is the systems/etc directory. And then you have the initial run disk, the kernel, and a number of other things, right? And again, you can run Geek system build with this particular configuration anywhere. You always get the same result. I can also do things like GuixSystem VM. And if I do GuixSystem VM, it's going to do essentially the same thing as GuixSystem build, but in addition, it's going to build a virtual machine image that runs the system I declared. And so what I get as a result here is a script that runs QEMU for that VM, right? Yeah, just to show I'm not cheating, yeah, this is the system that's booting. Trust me. And again, if I want to instantiate it in a container, I can do the same thing, but with GuixSystem container this time, and I'm going to get a script that spawns the container. Right, so I have one declaration, operating system declaration, and then I can instantiate it in different ways. And of course, I can instantiate it on the bare metal, but I'm not going to do it live because, you know. But I could do GuixSystem reconfigure, and I would essentially switch my system to that new declaration. So what happens at runtime? So we have this wonderful operating system declaration thing. And at runtime, when we boot GuixSD, what we get is, of course, Linux liber, so Linux without the proprietary blobs. And then we have an initial RAM disk that initializes, like, mounts the root file system, and it's actually written in guide scheme. And then we have PID1. So PID1 in our case is the GNU Shepherd, which is a very little known piece of software, I guess. It's an init system, right? So we're not using systemd or RUnit or one of these. We're using the Shepherd, which is also written in guide. So I show why it's interesting. And finally, we have applications which may or may not be written in guide. Yeah, some of them are still not written in guide. That happens. Okay, so before I've shown the so what you as a user will enter in your operating system configuration, and now I'm going to talk about the developer side of things, right? So how do you as a developer, as a GuixSD developer, define a service? So roughly the idea is that you specify, you know, a Shepherd service structure which has, you know, documentation requirements, so you can say what other services it depends on, and you can say how to start it, how to stop it, right? And here we have this hash tilde thing. If you're familiar with some sort of Lisp, you could think of it like quasi-quote, which means we're essentially introducing code here, literal code that will end up in the Shepherd itself. So it's not being executed right now, it's just, we're just producing code for execution at runtime, right? And so this is the code that the Shepherd PID1 is going to execute when we start MySQL. So we're essentially using the API of the Shepherd here. So we have this make fork exec constructor thing. It's a bit of an obscure name, but it's been there for ages, so that's how it is. Which tells, well, you know, to run MySQL, you need to call this command and with this argument, and this needs to happen as this user, that kind of thing. So that's the basic idea. But the good thing about Shepherd is that it's written in scheme, so we can actually like inject scheme in it. So if you think about systemd is written in C, and so when they want to add new features to systemd, it actually has to get into that C thing. So I mean, it's modular, but still you have to get into that C thing, right? It has to be within systemd. Whereas here we can just say, okay, well, the Shepherd doesn't know how to mount file systems, for instance. Yet it's a useful thing to do, right? So, so if you're familiar with systemd has this local fs.target thing to basically say, okay, I'm mounting all the local file systems. Well, we have something similar here. We have a file system service, and it needs to be able to mount file systems. So we happen to have a module in Guix that provides bindings to the C library, and in turn that allows us to mount file systems. So we just want to use this module here, and so we say, okay, I'm going to import those modules for the Shepherd, and then I can use my mount and umount procedures provided by this module. So essentially, without touching the code of the Shepherd, we've added new functionality to it, right? We've just imported the ability to mount and unmount file systems without actually changing it. So if you look at the Git repo of the Shepherd, you'll see it's quite inactive, actually. And one of the reasons for it is that, well, we can do things without actually modifying it. So that's pretty cool. Now for another example. So this is the typical, service for a daemon with the start method to launch the daemon. So BeetleB is an IRC gateway that I'm using on my laptop. I don't know if you're using it. It's pretty cool. So BeetleB is software that needs to talk to the network, obviously, right? But it shouldn't have to talk to have access to the file system like /home and so on, right? So we've been discussing like for a month that we need to be able to showcase why it's so cool to have the Shepherd in Scheme. So the previous example I gave about mount and umount, that's pretty cool, but it's still, kind of trivial, right? And so while on the train to FOSDEM, I thought, okay, let's make it happen. So the thing here, we want to be able to run BeetleB in a container so that at least we're reducing the attack surface. Well, we happen to have a container module in Guix itself, which is used for other things. And so why don't we just import it for that definition inside of the Shepherd so that we can run BeetleB inside a container? Well, that's what we are doing here. And it's a world premiere. And so essentially what happens here is that we just added this /container thing. So we're using a different procedure to start the process. But this procedure is not defined in the Shepherd itself. It's defined in our own module here. And it actually works, as incredible as it may seem. So this is my VM. Okay. Yeah, I'm afraid this is not super readable. But anyway, the thing is, I can use the herd command to ask the Shepherd about my BeetleB service, and it's telling me that it's running as PID 476. And so if I get into that container of PID 476 using Guix container, what's the story? Guix container exec. So I'm using Guix container exec 476.
Is it possible to change it to a white background with black writing? Or is it
I'm afraid this is QEMU. I'm afraid this is not possible. Yeah. Okay, but I just tell you what's happening on the screen. Essentially, we have a shell that's running inside that container. And if we look at /proc, /proc/ 0-9, we see there's only one process inside that container. So that's BeetleB running as PID1 inside that container, right? That's the story. Okay, so that's it for the world premiere. So far I've been talking about services that are typically daemons, right? And that use the Shepherd to be spawned. That's the main use case. So I'm going to talk about the story of services in GuixSD and how it went from sucking to being pretty cool. So let's start with our first take on this. So initially the focus when designing system services in GuixSD was like, well, all we need is something like, let's say, systemd unit files, right? All we need is to be able to describe dependencies among services, right? We want to be able to say, okay, first thing I do is to, mount file systems, and then there are user processes, and then there's syslogd, and there's a bunch of stuff up there that you don't need to worry about. But yeah, that's the main idea, right? We have a dependency graph. This graph is actually generated by a command which is GuixSystem shepherd graph. So you can, you give it a config file and it produces the dependency graph for shepherd. So that was the initial take on this. So essentially the model was well, you have a daemon and you just write service, start, stop, and you're done, right? Well, except that there are some cases where, before starting the daemon, you need to do some initialization, right? Like you need to create varlib, MySQL, something like that, right? So we added this activate field to our service structure to handle this case. Well, it turns out that, for some daemons, you also need user accounts, right? So, yeah, like for Postgres, you need a Postgres user account. So we added these two fields to our service structure to handle this case. And yeah, turns out that for some services, you also need PAM service declaration, pluggable authentication module service declaration. And well, for some services, you also need files at a precise location in /etc. So I think you see what I'm getting at, right? This is not very modular or extensible, right? We ended up adding fields in that service structure, and it didn't feel quite right, although it did the job for a while. And then it was like last year, or maybe a bit more than a year ago, Andy Ringo came to the mailing list and said, okay, GuixSD is cool, but I want to be able to run GNOME. Okay, fine. And to run GNOME, we actually need the whole free desktop set of services. Well, I was like, let's just add them, right? Okay, so what do we need? Well, we need udev and dbus to start with. Okay, that's simple, we have them. And then we need things like upower for power management and udisks. Okay, but dbus needs to know about upower. It needs its .service declaration thing that allows it to know that that upower is a dbus service. And same for udisk. So there is some sort of a connection between upower and dbus, but it's not like just, a daemon in the usual sense. It's something else, right? And udev also needs rules, these .rules files from upower and udisks, or just upower, I don't remember. Anyway, it needs info from those packages. So I was like, okay, we can hack something, we can manage it. So at this point, we were still fine, right? And then Andy kept explaining, well, turns out we also need polkit login and well, it would be nice if we had this thing called colord, which is for color management, and geoclue, which is a dbus service for geolocation used by some applications. And well, I was like, yeah, okay, well, how does that work, right? There are these arrows. These are not arrows like in dependency, in a shepherd dependency graph. It's something else, right? There are connections between all those services, but it's not completely clear what these are, right? It's about, passing files and pieces of information between services. And so at that point, we understood that we were essentially screwed, right? We had to do something about services in GuixSD. And to me, yeah, it really felt like, this example in particular, it felt like, spaghetti, right? But at the same time, we knew that we had something to do. And that's how it all started. So nowadays in GuixSD, we have composable services, and we can handle this kind of situation, and we actually have GNOME running and that kind of thing. So the key insight here from this free desktop example is that services, you could think of them as extending each other, right? So like colord, colord provides a .service file to dbus, right? So that you could think of it as extending the functionality of dbus in a way. And you have upower that provides udev rules to udev. which is sort of like, you know, extending UDEV. And that was the key insight when we started redesigning services in GuixSD. So I'm going to make a short digression to talk about how NixOS does things, because I had been working on NixOS before, and I obviously knew that they were doing better than we were doing. Right, so let's see how it works in NixOS. So this is how you would write a service definition in NixOS. So it's written in the Nix language, but again, without being a Nix expert, I guess you can understand what's happening here. And it's all pretty concise because you're just defining values, and those values have meaningful names, right? And the thing here about service extension is that NixOS seemed to get it right. So we can see here that SSHD is adding new users, it's extending what's in /etc, it's adding new services for systemd, all these things, right? So it's extending things in a way. There's a difference still compared, I mean, there are a few things I was not completely happy about it. So the great thing is that it's super versatile, right? From your service definition, you can change the whole system essentially, right? From PAM to /etc to systemd, right? And this is the really cool thing that we want to have. But the not so great thing is that in NixOS, you're actually building a big key value object, right? Key value dictionary that contains the configuration of the whole system. And so every service implementation received this config parameter as input, and config actually represents the whole system configuration, right? And from there, it actually produces additional key value pairs to add into that record, that dictionary. And you might have seen this thing also, the mkif. So the thing is, you can, in an NixOS service, you can look at the existing system configuration, but then it's recursive, right? It's actually a fixed point because you're looking at the configuration that you are currently building. And so Nix is a lazy language, but you have to pay attention to this thing, because if you don't do that, you might end up in endless loops, because you know you're looking at a data structure that you're building at the same time, that kind of thing. And also my main grief is that it has good structure syntactically. I mean, you can see the structure of things, etc, systemd, and so on. But then it doesn't, that structure is purely syntactic, right? You cannot really tell what's going on, how services are extending each other, right? You know that those arrows that I showed before, we don't really have them here. And so, yeah, this is what we want to have. So we have this, I would call it the system extension graph. So we have colored again providing .rules files, elogin, no, wait, what is it? geoclue providing .service files, and so on and so forth. And we want to be able to model that graph. Really, that's what we want to be able to do in GuixSD. So we can actually see what's going on and be pretty clear about what service modifies what other parts of the system, right? You shouldn't be able to just change any part of the system configuration. At some point, you have to precisely say, okay, I need to change /etc, for instance. But yeah, so this is the basic graph for free desktop. But again, if we look a bit further, well, we see this pattern in different places. Like dbus itself, you could think that it's extending the shepherd by providing a service definition to start it. And dbus is also extending /etc by providing /etc/dbus1, the directory. So this is again what we want to be able to keep on the user side of things, right? The users should still be able to have that simple list of values that they manipulate. And so we have some sort of a mismatch here because we want to have a model which is essentially a graph. Yet at the same time, we want users to be able to manipulate a simple list of objects. So how did we do that? Well, the thing here was to introduce a notion of services, which are first-class values representing services, which may or may not be shepherd services, and service types, which represent, classes of services. So let's see an example. Where is it? Oh, okay. So going back to my desktop service example, this is the ColorD service type. So this is how we define it in GuixSD. We define a service type, okay, and it has a number of extensions. So these are exactly those that I showed before in the graph, right? So it extends the so-called account service, meaning that it's creating new user accounts. It extends the activation service, meaning that it provides code to run when you boot the system, like creating varlib, ColorD, something like that. And then it extends dbus to provide its .service file. And we're making a distinction between service types and services because, so this is ColorD, so typically you have only one instance of ColorD running on your system. But in some cases, like SSHD, you may want to have several instances of them. So likewise, we have an SSHD service type, well, actually OpenSSH service type, and you can have several instances of this particular type. So in this way, we are defining the graph that I showed before, for all the services. And we can pretty much achieve what I showed for an NixOS, which is that you can choose which parts of the system you want to extend and actually define how you extend it. So for the account service extension, we provide user account subject. That's how we extend it. And then for the ColorD activation, we provide a snippet of code. For dbus, we provide a package object. And then what do we have here? And for Polkit, we provide Polkit actions, which are themselves contained in a package object. So this is all, we have disjoint types for all these things, so we can know precisely what it is that we are manipulating, right? So it's not like this, key value dictionary that I showed before. You have to be very precise about the types that you're manipulating and things that you're providing as extensions. Right. And then once we have that, we can use that Geeks system extension graph command, and we can visualize how the system services are composed, which is, I think, pretty unique to GuixSD. And so even for a simple system like I showed before, with essentially just the basic services plus SSHD, we get a graph that's already, kind of big. But essentially, we find the same things as before. So at the top over there, just above the screen, we have OpenSSH, and these pinkish arrows actually show what OpenSSH extends. So we can see that it extends the activate service, the account service, and the shepherd, right, PID1. And yeah, and we have a bunch of other extensions going on here. Now, if we look at that example, that supposedly simple free desktop example, well, it's still spaghetti, right? But at least we can visualize those spaghettis, and that's right. That's probably an improvement, I guess. But more seriously, it allows you to reason about what's going on here, kind of. So if obviously you have to zoom in to get a feel of what's going on, but essentially we see GNOME that's extending, what is it, Polkit, and Polkit is doing a thing with udev and whatever. So we can. Right. Well, the details don't really matter here. It's just to show that, yeah, we have a well-defined structure of services and service extensions, and we can visualize it. That's the story. So at each step on this kind of graph, we're manipulating different types of objects. So if we go to Polkit, for instance, Polkit is concerned with policy rules, whereas UDEV is concerned with UDEV rules, and the account service is concerned with user accounts, right? And at some point it has to be folded into something that's low level, right? That's close to what you have on disk. And this is why at the bottom here, just below the screen, this time, we have one node, which is the system. So you remember when I run gig system build, I got one directory as a result. Well, that's this node here at the bottom. So the system is a service that's itself extended by all these things. So what that means is that we need to be able to fold values and to sort of compile them from this high level, like user accounts, UDEV rules, into something as low level as files on disk. So how does that work? Well, there is a fold services procedure that I don't know if I'm going to be able to present. Maybe yes. Maybe yes. Okay. Let's do it. Okay, so Alex showed you the geyser and the REPL and all that, so you're probably super familiar with it now. So essentially, I'm running guide here, and I'm saying, okay, I want to load my operating system configuration like this, and I get an operating system object. And from there, I can do, like, I can query it, like, how many system services do I have in there? Well, I have 27 of them, fine. And now, how do I actually compile these to those low-level files on disk, essentially? Well, I can use this fold services thing. It's not in my history. So I can say operating system services. If I give no arguments, then I'm getting as a result a single value, which is the system service, right? And if I look at the parameters field of that value, it's actually, well, the system itself, right? The derivations that build the system. But I can also stop at intermediary levels. So I can say, okay, this time I'm specifying a target system type. Let's say etc service type. I'm getting this huge value, which actually represents all the files that are going to end up in /etc, right? So I can do some sort of a step-by-step compilation of this high-level declaration to what's going to end up on disk. And any Haskellr in the room? So this is a monoid, I think. So just to conclude, I think the takeaway message is obviously that this, we leverage a holistic approach to system services, right? So more seriously, so the initial idea that essentially a systemd unit file is what a system service is turned out to be flawed, right? System services are more than just actions to start daemon, stop daemon, stuff like that. It's more than just this dependency graph. And service extensions, as I showed, they capture all these aspects of service configuration and how they interact with each other. And it makes complex configuration tractable. So there is a Gix contributor, maybe somewhere here, Christopher Baines, who has been using it at their workplace to actually build very complex kind of things like rep services in Ruby that extend the Nginx service, which in turn does crazy things that I don't really understand. But yeah, like complex configuration like those that you have on web services, you can handle them in this way, and you can still reason about them and find out what's going on. And that's pretty cool, I think. And so you should come up with your own system services, because then the limit is imagination, right? I mean, you can think of very high level services like I don't know, GitLab service, or something that provides a big service, and in turns you can decompose all the details of what's going to happen. And that's pretty cool. So you're welcome to join us in having fun with GuixSD. And that's it. Any questions? Yep.
So it's really interesting, like the kind of service graphs that you were showing, you basically execute this with a Geeks command, right? So it's basically they're generated on the fly from a description, system description.
Right.
It seems that is a really interesting way also for other like complex software projects to try and model, like just to visualize their dependencies in a visual way. Right?
Yeah.
Like, yeah, thinking of my work environment of like providing web service that depend on Nginx and on MySQL databases, so it would just be really nice to see exactly all the things that are involved in the dependency graph there.
Right. So yeah, so just to repeat, your comment is about visualizing graphs in general and how you combine things, right? I think it's pretty useful, and actually I was really jealous of Justus yesterday in the Her talk, because I would have loved to have a D3.js kind of thing where you could, show how you compile services down to the final value. Next time maybe. Other questions? Do we still have time?
Yeah, it's still time.
Yes. Oh, Sander.
Yeah, so I'm actually curious about the performance. So what if, for example, you have a reasonably complicated configuration and you want to build that? Is it fast or is it slow? Can you say anything about it? And also about, for example, the memory consumption evaluated.
So the question is about memory and CPU usage when building a configuration, and a complex configuration. So I think I don't have any concrete figures. And also, I've never really toyed with configurations that are really that complex. I mean, a desktop configuration already has some complexity, but maybe not as much as the web services I mentioned earlier. So you've seen it in action. It takes like, I don't know, maybe a couple of seconds at least where things are already in store. I haven't done any memory usage measurement. It's not super efficient probably, but still not maybe, I remember with large NixOS configurations you could have huge memory hogs. I think it's probably less bad, but again I haven't done any measurements, so I can't really tell.
Still have 3 minutes.
Yeah, other questions? Or maybe a break? Okay, thank you.